And so the Earth is divided into these various tectonic plates. And so here, what these are showing is the converging plates where they're coming together and one's sliding underneath the other one. And this is like in the South America. By the way, this is why you have the biggest earthquakes in the world happen here, and they happen here, and they happen here, and they happen here. Okay, anyway, the ones with the teeth there, those are converging plates. These are like the mid-Atlantic ridge. Those are diverging when they're moving away from each other. Here we have a diverging plate of the Pacific Ocean. And notice the Pacific plate is moving out that way. And now the types of boundaries. Please write this down. Types of boundaries. Okay, first type of boundary. If you need more time, just pause the video. The first type of boundary is divergent boundaries. And this is where plates are moving apart. Write this down. If you need to pause it, go ahead and pause it. But divergent boundaries is like we learned about with the Mid-Atlantic Ridge already. Now, some of them have ocean to ocean moving apart. That's what you get in the Mid-Atlantic Ridge. So you can have an oceanic ridge, and here's where new seafloor is being made. And again, we already learned about the Mid-Atlantic Ridge. That was the first one discovered, and that was still what would be considered the most important one. Now, the Pacific Northwest, we have our own plate, basically. It's called the Juan de Fuca plate. You know how there's the Strait of Juan de Fuca? Well, the Juan de Fuca plate is what it's called. And of course, out of that plate, we have a diverging boundary that's moving apart. It's the Juan de Fuca Ridge. Now, sometimes you have in the middle of the ocean where they're spreading, but what would it have been like to be in the middle of Pangea when it started to split? Well, it's called rifting. When you have a continent that is actually tearing itself apart in super slow motion, what you have is a diverging boundary in the middle of a continent. And what would happen then is Pangea in the middle, you had the volcanoes and stuff, and it would have moved apart. It's called a rift valley there. And ultimately, it would have spread apart enough to be the Atlantic Ocean. Well, it turns out there's a spot on Earth that is happening right now in Africa, in East Africa. There's this area, it's called the Rift Valley. The Red Sea, as a matter of fact, is right there where it's getting wider every year by about an inch. And this area here in Africa is splitting apart and it's leaving these what's called rift valleys, which have some of the longest lakes in the world, Lake Tanganyika and these others of down here in this area of Africa. And so here's a view from space. And this lake looks like it's being torn apart. You know why? Because it is being torn apart by tectonic forces that are tearing Africa apart in super slow motion. Now, it's going to take millions and millions and millions of years, but these lakes will become wider, wider, and eventually will be seas, just like the Red Sea up here is, right? And so here's a picture of Lake Victoria from space. Again, this is a crack in the Earth's crust in Africa that's filled with water, and it's a lake, and you know, many people live around it and go fishing and all that kind of stuff there now. Here's, I wish I could find in English. This is the best graphic I could find of it. But you also have these string of volcanoes because that's where the mantle material is coming to the surface, right? You're having volcanism just like would make new ocean floor. Well, it's coming up with these volcanoes, and these plates are moving apart in opposite direction. This one, of course, is in German. The Afrikanische Platte, the Somalia Plata, Indische Plata, Arabische Plata, and volcanoes, right? Okay, so anyway, I couldn't find it in English. Oh, but here it is in French. Blick Africain, Blick Somalian. Anyhow, Africa is a rift valley that's a diverging boundary in the middle of a continent. And that's what would have happened in Pangea when Pangea was being torn apart back in the early days, 250 million years ago. Now, the next type of boundary we have is the converging boundaries. And a lot of it we're going to be dealing with these converging boundaries where plates are coming together and subducting. Everybody, please write this word down. Subducting. Now, this concept of subduction, right? They're one subducting underneath the other. So now, when they first discovered this thing, it was pretty confusing. They were going, "Oh, wait a second. You got new seafloor being made. Does that mean the Earth is getting bigger and bigger? And is it just growing?" And there were actually some scientists that were speculating about that. There's still some crazy people that think that that's really what's going on, but it's not. What's happening, and they know this by measuring the depths of earthquakes, when you get where two of them are coming together and one starts to dive underneath the other, okay? The reason they know for sure that's happening is by detecting the earthquakes that happen at different depths. They have ways of analyzing the seismic waves and to understand how far away an earthquake is, so how deep it is as well. And so, since they could detect the earthquakes getting deeper and deeper, they know that they're sliding down one underneath the other. That's called subduction. Subduction. This is really important. We live in a subduction zone, by the way, and that's why we have the Cascade Mountains. That's where we're going with this. Okay, subduction. Everybody say it? Subduction. They are subducting one underneath. And so the Earth isn't getting bigger. The Earth is staying the same size, but the oceanic crust is being formed. Meanwhile, it's getting destroyed somewhere else where it dives underneath back down into the Earth's mantle. Okay, so you have a subduction zone. And that can happen when you have oceanic crust and continental crust. That means there's ocean plate here, and there's this big slab of granite, which are the continents, and one is diving underneath the other. Now, the ocean crust is thinner, so it's going to be the one that slides underneath. By the way, this here picture, we're going to come back to this because this right here is what we have in the Pacific Northwest, and it forms mountains, basically, and it goes back up and it becomes a string of volcanoes, and that's what the Cascade Mountains are. We'll come back to that. So we aren't even going to draw this picture yet. We'll draw other pictures in a little while, okay? But instead, we'll get to the oceanic crust. When you have an ocean plate, one dives underneath the other. It's going to burble back up and become what's called an island arc. Now, this is really important when remember you guys did that project on the Ring of Fire? Well, a lot of the Ring of Fire are these island arcs. Okay, let's take a look at Google Earth a little bit. Let's look at some of these island arcs and some of the other features that found in the Earth. Remember, it was pretty important, the discovery of being able to map the ocean floor, where they found these underwater mountain ranges they never knew existed. Well, it's more than that. There's not only underwater mountain ranges, there's underwater trenches that are some of the biggest structures on the whole planet. They didn't even know they existed for a long time. So let's take a look at Google Earth then and see what it can show us. Okay, now here's that Rift Valley I was talking about a little while ago, in Africa, right? But if you go, here's the Mid-Atlantic Ridge in the middle of the Atlantic Ocean. If you go to the Pacific Ocean, you guys did the little project on the Ring of Fire, so you know that the Pacific Ocean is ringed with volcanoes, right? Well, here's why. Because the Pacific Plate is sliding up in this direction. It's moving northwest, okay? And when it does, it slides underneath the North American plate here and underneath the Asiatic plate here. And what happens when it's sliding underneath, it has a trench, these deep, deep trenches. These are the deepest parts of the whole ocean. And right along them is a string of islands. These islands, they have volcanoes on them. That's what's really going on there. These are called an island arc, okay? And underwater, and they never knew that these things existed underneath the ocean. You can't see them until they got diving technology and sonar depth finding technology to be able to figure out, whoa, they got these giant, enormous underwater structures. Nobody even knew it existed. And so here's the Aleutian Trench, and this is the Aleutian Islands, Aleutian Islands. And then here's the Japan Trench, and there's the Japanese Islands, which you probably know are volcanic, with Mount Fuji and those guys, right? And then you get these various trenches as the Pacific Plate slides underneath. You got the Mariana Trench, which is the deepest part of the whole ocean. The Philippine Trench, where the Philippine Islands are. Mount Pinatubo was a volcano that erupted not too awful long ago. So these are what's called island arcs, okay? A string of volcanic islands that just roll right along parallel to these trenches. You got the Tonga islands in Japan and all that kind of stuff. And also these trenches here with our, there's another plate, the Pacific plate. Well, over here there's called the Nazca plate. And here it's diving underneath South America. So you have another plate with a string of volcanoes. And then our coast, you have a trench, which isn't as deep as the Pacific Trench, but it's a trench and a string of volcanoes. This seems to be a pattern. So let's go ahead and draw a picture of what's going on when you have oceanic plate and oceanic plate. So get your piece of paper, have a pen ready.